First units are set to be on the line by the end of this year, and we'll be ramping the factory throughout 2026. The factory is designed with an annual capacity of 50,000 units a year.
Body in white facility commissioned, production tooling now being installed. 4680 cell line has exceeded 100 million cells produced. PepsiCo and WattEV are scaling commercial fleets. The Megacharger infrastructure is being fully deployed. Series production locked for the fourth quarter 2025 with a full-rate manufacturing ramp in 2026. Everything is on schedule, and nothing can stop it. If you judge an industrial project by concrete, steel, and the speed at which both are turning into product, the Tesla Semi is suddenly very real. 2-day-old drone passes show stacks of painted chassis rails, suspension modules, and cab floors queued outside the newly enclosed semi-wing at Gigafactory, Nevada. Inside, cranes are lowering the first body-in-white robots and paint booths into place. Now Tesla is truly focusing on the launch of the factory, which will put production into full swing, moving into 2026. Earlier this year, Lars Moravy, Tesla's vice president of vehicle engineering, gave an update on the Semi and the company's current timeline for the product.
Builds of the high-volume Semi design will come late this year in 2025 and begin ramping early in 2026. But as we've said before, the Semi is a TCO no-brainer. Like, it's really similar to the Optimus. It's set by how much people pay, and then it as the total cost of ownership, it's much, much cheaper than any other transportation you can have.
Over the past several weeks, observers at Tesla's Nevada campus have noted a pronounced buildup of semi-truck components just outside the newly completed assembly hall adjacent to Gigafactory, Nevada. In particular, dozens of bare chassis frames, each comprising the foundational steel rails, crossmembers, and suspension mounting points, have been neatly stacked in parallel rows across the concrete pad. Alongside them sit palletized subassemblies, axle housings, battery pack modules, and steering knuckles, all awaiting their turn on the production line. This conspicuous accumulation of raw semi-elements offers a clear signal that Tesla is on the verge of transitioning from trial builds to low-volume series manufacture. This visible progression, from chassis stockpiles to enclosed equipment-filled bays, strongly suggests that Tesla intends to commence limited pilot production of its Class 8 electric truck within the coming weeks. Industry analysts have noted that the quick succession of site build-out, equipment installation, and part staging typically precedes the first burn-in prototype runs, where complete vehicles are cycled through charge, discharge, and drive tests. Should these initial units prove successful, Tesla is poised to ramp up throughput to reach a sustainable monthly build rate by year's end. Ever since Tesla first teased its Semi back in 2017, one thing has always been clear. You can't revolutionize trucking without the batteries to power it. That's why the rollout of the 4680 cells in Nevada is such a big deal. Let's dive into the nuts and bolts of what's happening under the hood and around the yard of Tesla's Big Rig program. Tesla has never pretended the PepsiCo pilot fleet is the final form of its Class 8 Challenger. In fact, Priestley opened the April update by ticking off the changes coming on the Gen 2 Semi. First, a visibility makeover.
We have a new mirror design. Better sight lines, better aerodynamics, better performance overall. On top of that, we added a drop glass. There's a lot of fixed infrastructure, whether it's gate operations or interacting with a port or telecom. These will make drivers' lives easier.
Those mirrors answer a loud complaint from veteran haulers who found the camera-only arrangement unnerving in tight traffic or when backing into a dock. The drop-glass side windows, meanwhile, restore the universal trucker habit of making eye contact with gate guards or port crews. In short, form is finally catching up with function. Tesla just crossed the milestone of 100 million in-house 4680 cells, doubling production in just 9 months. That's no small feat. It means Tesla is laying the groundwork to actually have enough juice for a proper production ramp in 2026. Think about it. The Semi's 500-mile long-range pack needs over 900 kilowatt-hours, so every extra million cells brings you closer to rolling these trucks off the line without scrounging for batteries elsewhere. Priestley's bigger news concerned the pack between the frame rails.
And then one other thing, we have a new HV battery. Now this battery brings in our latest and greatest in terms of technology. It is cheaper to manufacture, and the best part is that it's actually less battery energy than in our current pilot production vehicles. But it maintains the same range. This is achieved through efficiency improvements that we're showing here, more than 7% at this point.
Industry watchers expected a straight swap to 4680 cylindrical cells, but Tesla is rolling out an all-new high-voltage architecture instead. Less battery mass means higher legal payload, a decisive advantage in a business where every pound of freight turned away is revenue lost. Battery progress only matters if you can refill quickly. Tesla's answer is the Megawatt charging system. V4-based cabinets that push 1.2 megawatt to a semi, or share that power across up to 8 posts. The math is blunt. 30 minutes on an MCS adds about 350 miles of range. For long-haul operators who live on tight delivery windows, that is the difference between making the next slot or eating a detention fee. Now, let's talk about megachargers. Tesla has announced 46 megacharger sites across the U.S., all scheduled to go live before 2027. The first public station, outside any factory walls, is under construction in Southern California, and Frito-Lay is already adding 8 stalls at Bakersfield after Modesto. These are more than 1 megawatt chargers. Tesla brags about replenishing 70% capacity in 30 minutes, and at under 2 kilowatt hours per mile, they can push the big pack out to 500 miles on a single charge. That's something no other electric truck on the market can touch right now. The speed of the Nevada build has taken skeptics off guard. In January, the north wall was skeletal. By May, every bay was sheeted and crane rails were humming. Rack after rack of completed frames, stacked like Lego bricks, sit on the asphalt while crews finish utilities inside. The choreography matches Tesla's habit of staging parts outside weeks before a new line goes hot, a tactic that let the Shanghai Model Y shop sprint from dirt to first body out in 10 months. You can't call something road-ready until it's logged real miles. Tesla's semi-test fleet, made up of company rigs and partner trucks, has already racked up 7.9 million miles, with 26 trucks each surpassing 100,000 miles. That kind of endurance testing isn't just for bragging rights. It's how you shake out bugs before handing a rig over to a big fleet customer. Speaking of which, PepsiCo was first up. After taking delivery of 36 semis in Sacramento and Modesto, they just ordered 50 more for their Fresno hub, complete with 8 750 kilowatt chargers and 2 megapack storage units. And then there's WattEV, which inked a deal for 40 semis, getting 2 units now for a Long Beach trial and full delivery slated in 2026. When your launch customers double down like that, you know there's serious confidence in the product. Elon Musk famously called the Semi a money machine, and the arithmetic holds. Diesel prices have eased since the 2022 spike, but electricity remains roughly half the cost per mile. Independent audits by PepsiCo and DHL logged real-world energy use approximately 1.7 kilowatt-hours per mile, translating to fuel savings of 25 cents to 35 cents a mile. Over 300,000 miles a year, even a $250,000 sticker pays itself back in 3 to 4 years, long before OEM diesel rigs cycle their first in-frame rebuild. Demand hasn't been an issue. Orders from Walmart Canada, Cisco, United Parcel Service, and more are still queued up. But as of today, only a few dozen trucks have been handed over. The real stress test comes in 2025 to 2026, when Tesla will have to prove that the Semi's total cost of ownership beats out diesel at scale. Can the operating cost savings, thanks to sub-2 kilowatt-hour per mile efficiency and lower maintenance, offset a higher sticker price? Time will tell. America needs about 80,000 more commercial driver's license holders than it can find, and attrition is brutal. Musk's counterpunch came in last quarter's call.
I think ultimately we'll make over millions probably, of the Tesla Semi. This is really going to be something that you'll see all over the place, and it'll also be autonomous, or have the ability to go autonomous down the road.
Full self-driving on a Class 8 chassis is more than a party trick. The biggest drain on fleets is hours of service downtime. A truck that can legally move while its human crew rests reshapes route planning, asset utilization, and, critically, the appeal of the job itself. Tesla engineers also added a feature called electric power takeoff, which can deliver over 25 kilowatts of either alternating current or direct current. By tapping into the Semi's high-voltage battery pack, electric power takeoff lets the truck power refrigerated trailers, commonly known in the industry as reefers, directly, eliminating the need for separate diesel generator units, hydraulic pumps, or even cement mixers off the main pack, replacing trailer diesel gensets and bringing silent, fume-free operation into distribution yards that already face heavy air quality scrutiny. Medium and heavy-duty trucks burn a quarter of U.S. transport fuel, yet make up barely 4% of vehicles. Swapping a diesel rig that averages 6 miles per gallon for an electric tractor at 1.7 kilowatt-hours per mile offsets roughly 75 tons of carbon dioxide per year, per truck. Bill Gates once argued that batteries will never be a practical solution for long-haul freight. Real trucks, real loads, and real customer data now say otherwise. Of course, no mega project is without its hiccups. Tariff volatility between the U.S. and China in early 2025 forced Tesla to pause imports of Semi and Cybercab components, prompting a wholesale re-evaluation of growth plans for the next quarter. When Uncle Sam in Beijing start swapping tariff salvos, even a well-oiled machine like Tesla has to hit the brakes. Skepticism is healthy. Tesla has missed dates before. Yet the skate plan visible in Sparks copies a playbook honed across 6 gigafactories, modular lines, vertical integration, and ruthless iteration. With the 4680 cell ramp in Austin feeding Cybertruck demand, Nevada's new high-voltage pack can tap existing 2,170 capacity or outsourced prismatic suppliers without draining Tesla's core automotive programs. So what's the outlook? If Tesla stays on track with equipment installations, we should see the first mass-production semis rolling out by late 2025, with a serious uptick through 2026. The two biggest choke points? 4680 cell output and the Megacharger network, and by all appearances, both are making solid progress. Electric trucks are not magic. A battery fire last summer on Interstate 80 shut the highway for 16 hours after a Semi hit a tree, underlining how stubborn lithium-ion chemistry can be once breached. Yet even factoring in those challenges, the commercial signal is unmistakable. With every chassis stacked on the Nevada apron, every hiring post, and every kilowatt pumped through V4 cabinets, Tesla is converting hype into throughput. But here's the bottom line. Tesla isn't just building an electric truck. They're laying down a whole ecosystem of battery production, high-power charging, and real-world validation. Sure, there are supply chain speed bumps and infrastructure challenges, but every week brings new cell lines online and new megachargers spinning up. If Tesla can nail the late 2025 production start and keep ramping into 2026, the Semi might finally make good on the promise to transform heavy hauling. Whether you revere Elon Musk or revile him, the scoreboard of execution now sits in Nevada dirt, stamped in steel, and ticking toward a 50,000-unit annual cadence. When those first production semis pull out of Sparks. Next year, America's truck stops will showcase not just another EV, but a proof of concept that could redraw the entire cost curve of moving goods. With the U.S.-China tariff cloud finally clearing, Tesla wasted no time. The company immediately placed fresh orders for both Semi and Cybercab components. That unblock in supply chains not only ensured that the big rigs can keep rolling toward their late 2025 ramp, it also jump-started progress on the Cybercab program, meaning both the heavy haul and next-gen cabin platforms are now surging forward in tandem. So could the recent easing of US-China tariffs, just as Tesla locks in a robotaxi launch date in Austin, mean that the long-awaited Cybercab is finally about to hit the streets sooner than we ever expected? Could the recent easing of the US-China tariffs, just as Tesla locks in a June 12th robotaxi debut in Austin, mean the long-awaited Cybercab is finally about to hit the streets? A closer look at both developments suggests that Tesla's timing may be more than coincidental. When Bloomberg first reported that Tesla plans to launch its fully driverless robotaxi fleet in Austin on June 12th, CEO Elon Musk confirmed on X that people should be able to fly to Austin and hail a robotaxi by the end of June, highlighting the company's rapid push to get autonomous Model Y units circulating in real traffic without a safety driver behind the wheel. To pull that off, Tesla needs a production-ready cabin platform tailored to ride-hailing. Enter the Cybercab, a purpose-built version of the Model 3 and Model Y chassis, with a reimagined interior and sensor array designed specifically for autonomous service. Yet, just weeks before, Tesla found itself scrambling. In early April, U.S. tariffs on Chinese-made components spiked to as much as 145%, prompting Tesla to suspend plans to ship components from China for its Cybercab and semi-electric trucks. According to Reuters, that move threatened to derail not only Tesla's massive rig ambitions, but also the Cybercab's readiness for a June rollout. Without critical castings, sensor housing, and interior modules flowing from Tesla's suppliers in China, Giga Texas risked running short on parts just as it prepared to weaponize its new cabin for robo-taxi trials. Then came the US-China tariff truce in mid-May. In a swift policy turnaround, Washington slashed extra duties on a broad swath of Chinese imports from 145% down to 30%, with Beijing reciprocating by cutting its retaliatory levies on U.S. goods from 125% to 10%. Almost immediately. But if the Cybercab rollout in Austin goes smoothly, it could mark a pivotal shift. Not only for Tesla's autonomous ambitions, but for the entire ride-hailing industry. Where competitors like Waymo have spent years and billions developing purpose-built robo-taxis, Tesla's approach of iterating on existing platforms and leaning on its global supply chain has always been a bet on speed. The tariff truce and the hard date for robotaxi launch suggest that, at least for now, Tesla's gamble is paying off. Considering the recent price increase rumors and initial sticker estimates from $150,000 up to $400,000 or more, what do you think is a fair launch price for the Tesla Semi to truly disrupt heavy-haul trucking? Please share your opinion in the comments section below this video. Thanks for watching our video. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to subscribe to Tesla Car World and turn on notifications so you never miss our latest videos. We appreciate your support and look forward to seeing you in the next video. Goodbye.